Dear students, these are the three kinds of setups done by Faraday and Henry, which shows that how EMF or current can be induced. There are three different methods. Let's focus on the first one. Here you can see that here it is a coil which is connected to a galvanometer, and this is a magnet. Right? When this magnet is moved, it is observed experimentally that when this magnet is moved toward the coil, this galvanometer shows deflection. When it is moved away from the coil, again the deflection is there in the galvanometer but in opposite direction. Right? So this shows that when we are moving, when we are keeping or we are moving the magnet toward the coil, in that case the flux associated with this coil is changing. Since we know that the field is maximum, strength of flux lines or strength of magnetic field is maximum near the poles, okay, and it goes on decreasing as we move further away. So when we are taking this magnet toward the coil, it means we are increasing the strength of magnetic field lines inside this coil, and since the strength is increasing and the galvanometer is showing direction deflection, it shows that change in strength of magnetic field is producing current or EMF. Similarly, when we are taking it away from the coil, in that case the strength in the magnetic field decreases, strength of magnetic field in the coil decreases. Again the coil shows a deflection. This shows that again the current or EMF is being induced when the magnet is taken away from the coil. But it is actually find out when this magnet is moved toward the coil and is then kept at a single place, means there is no movement of the magnet. In that case there is no deflection observed in the galvanometer, which shows that since the magnet is stationary at its own place, it means the magnetic flux linked with the coil is fixed, constant value. So galvanometer is showing no deflection. So this shows that whenever there is a change in magnetic flux associated with the coil, the current or EMF will produce only then. Okay, and one more thing, when we are taking the south pole toward the magnet, again the deflection will be produced, but that will be opposite to as is the case with the north pole. So this experiment shows that the magnet movement leads to change in strength of magnetic flux, which leads to production of the current. One more thing is to be noted, that when this magnet is rotated about its own axis like this, there is orientation, there is, we can say that change in position. Suppose we are changing its position also like this, but in both cases there is no deflection observed. Why this would happen? Because in both cases we are changing the position, but the strength which is reaching the coil is fixed. When we are rotating this magnet, again the strength is same. So it means that changing the position within the coil vertically, okay, and rotating the magnet at its own place will not change the flux, and hence no current or EMF is being induced. Similarly, the same experiment was performed by taking a current carrying coil. In this case, the current induced by current. This shows that this is a coil and this is connected with a battery, so current starts flowing through it. Now since this is a current carrying coil and this current is steady current, okay, so in this case magnetic flux will produce, this current carrying coil will produce the magnetic field. So when we bring this setup near to this coil, the deflection is observed. When we take this setup away from the coil, current is again induced. But if we keep this along with this coil at some fixed position, no current is observed. So this experiment also shows that whenever there is a magnetic flux linked with the coil changing, current will induced. third case is current induced by changing current. In this case, you can see that this coil is connected with a battery and a tapping key. So it is observed experimentally when we close the key. We tap the key, deflection is produced. We switch on the key, deflection is produced. But when we keep on closing the key or we keep on the key, in both cases no deflection is being observed. It means that whenever we change the current, in this case current will be induced. Now why this would happen? This is because when we switch on the key, current is increased in the coil immediately from 0 to maximum. So magnetic field will produce from 0 to maximum, and accordingly the magnetic field strength to this coil changes from 0 to maximum immediately and deflection is produced. But when it is kept on in contact, in that case the magnetic field is maximum, and here also the magnetic field is maximum. Since there is no change in the strength of the magnetic field, so no deflection is being observed. Similarly, when we off the key, in that case the current immediately changes from maximum to 0. Current changes from maximum to 0, so magnetic flux will changes from maximum to 0 and deflection is observed. But when we keep it off, in that case the magnetic field is 0 associated with this, is 0 associated with this, and hence no deflection is being observed. So from all these experiments we come to know that whenever there is a magnetic flux linked with the coil changes, the current or EMF is induced, which is the basic cause of electromagnetic induction. So we can write here basic cause is whenever the magnetic flux EMF or is induced in a coil, EMF is induced in a coil only when the amount of magnetic flux linked with coil changes. Okay, so that's all about it. Now in our next video we will discuss about the Faraday's laws of electromagnetic induction.